Hello, my name is Higashino from Z Engineering. For the past 42 years, we have been working with steam traps. During that time, we have seen steam systems in many different factories. This YouTube channel is not meant to defend or promote Orifice traps. Instead, we will talk about the real problem that's actually occur in steam system in the field, and how we have tried to find answers to those problems through our work on site. That is what this channel is about.
There are situations where orifice traps cannot be used. This is not a design mistake. It is the physical limitation of a single orifice design. Today, I will explain why this limitation exists and how the multi-stage structure changes the situation. A single orifice trap controls all flow through one small hole. If the hole becomes larger, more condensate can pass, but steam begins to leak. If the hole becomes smaller, steam leakage stops, but the trap becomes easier to clog. In other words, discharge, capacity, and stability cannot both be maximized. This is the physical limitation of the single orifice design. A single orifice has a limited operating range. This graph shows the discharge capacity of an orifice steam trap. The horizontal axis is differential pressure. The vertical axis is discharge capacity per hour. The discharge capacity is determined by two factors: differential pressure and orifice diameter. As differential pressure increases, discharge capacity also increases. Now look at this graph, this blue line. This line represents the maximum discharge capacity of the orifice. Any flow above this line is physically impossible. If condensate exceeds this limit, discharge failure occurs. In other words, there is a clear upper limit to the amount of condensate that can pass through the orifice. Now, look at the red line. This is the steam leakage line. Below this line, steam begins to leak, which means there is also a lower limit for condensate flow. The only safe operating zone is the space between these two lines. This is the usable operating range of a single orifice trap. If condensate flow is unstable, the operating point moves outside this range. That is why a single orifice trap cannot work in unstable conditions. This is not a performance issue. It is a structural limitation. So the question becomes, what can we do? This is where the idea of a multi-stage structure appears. A single orifice trap controls flow with one hole. A multi-stage trap works differently. It reduces pressure step by step while discharging condensate. By dividing the pressure drop, the system can respond to changes in condensate flow. This improves the stability of condensate discharge. The control is not achieved by hole size alone. It is achieved by dividing the pressure. This is a completely different idea. Now look at the structure. Inside a multi-stage trap, there are plates with small orifices and ring-shaped spacers. These components are stacked alternately. This creates small spaces between the plates. Those spaces allow the pressure to drop in stages. In a single orifice trap, flow always occurs under the full differential pressure. But in a multi-stage trap, the effective pressure changes depending on condensate flow. When condensate flow is small, the differential pressure decreases. Steam leakage becomes less likely. When condensate flow increases, the pressure difference increases. More condensate can pass. The differential pressure adapts to the condensate flow. This is why the usable operating range is much wider. Look at this comparison graph. On the left is the multi-stage trap. On the right is the single orifice trap. The multi-stage trap has a much wider operating range. By dividing the pressure drop, the usable range becomes significantly larger. There is one important point. A multi-stage trap is not simply an improved single orifice trap. It is a completely different design philosophy. The way pressure is handled is fundamentally different. Single orifice traps have a physical limitation. Multi-stage traps overcome that limitation through a new concept and a new structure. This is the key point to understand. In the next episode, we will discuss another limitation of the orifice principle. Why is it difficult to design a very large single orifice trap? Why does the single orifice concept reach its limit? We will explain this from a physical perspective.